Hello. Actually, I have one. Yes, it's there. Right, excellent. Okay. Welcome, everyone. Thank you for coming to this talk. As you know, this talk is really about JavaEE 7. We'll talk a little bit about the JavaEE 7 APIs that are coming out, actually have come out already. The spec went final about a couple of weeks ago. I will talk a little bit about JavaEE 8 and what's coming beyond, and the primary goal there is really to get you engaged and get your feedback on what you think is important for you, of course. My name, of course, is Rez Rahman. I'm a JavaEE Glassfish evangelist. I'm relatively new to Oracle. I joined Oracle last September, last Java 1. Before that, I was a JavaEE, I guess unofficially a JavaEE evangelist. I was an independent consultant for many years in the New York, Philadelphia areas. I wrote a book called EJB3 in Action, and I have been involved in the JCP for a long time as well. So I've been involved in E5, E6, E7, EJB3.2, EJB3.1, JMS2, and the like. I've also contributed to the resin container. I wrote the EJB container for resin 4. Okay, so a standard Oracle disclaimer. Basically what this is saying is don't do anything like writing contracts based on what I tell you. Anything that I tell you can change. This disclaimer will go away probably in about a week or so. Okay, so the basic agenda for today is to do an overview of what EE7 is about, give you a taste of the API changes. Of course, in a 50-minute time slot, I can only do so much of that. So my goal is to really show you the primary characteristics of each of the APIs that are going into EE7, and with the hopes that I'll interest you enough so that you can either go to the other sessions that are about specific changes in these APIs, or do some of your own research. And of course, as I mentioned, a little bit of looking ahead into the future. So before we dig too far into the future, I just want to show a brief overview of how we got here. So as you know, JavaEE isn't a new technology. It's been around for a very, very long time. And it's gone through several iterations of evolution. The latest evolution being EE6. You know, the EE6, I think, was a very fundamentally important release for the JavaEE ecosystem. So it saw things like CDI in terms of standard dependency injection in JavaEE, pruning of some older technologies, extensibility as a goal of the fundamental goal of the platform, things like JAX-RS2, things like Servlet 3, things like JV3.1 Lite. The other thing that a lot of people still don't realize is that as of EE6, the JavaEE platform was actually split into two different parts. There's now the full profile, you know, all of the larger application servers, or rather the predominant application servers would implement those profiles. They'll implement all of the APIs. But also, there's a smaller profile, smaller subset of APIs called the web profile that you can implement as well. So things like Resin and Tommy and the like would implement the web profile. So talking about EE7, the theme that I guess Oracle's idea of the theme of Java EE7 is productivity and HTML5. What that really means is that first and foremost, there's a few APIs that were added in support of, you know, all of the changes that are going on in the web standards themselves. Things like WebSockets, things like Xforms and the like in the HTML5 space, as well as some changes, incremental changes in the existing APIs to make them a little bit more productive, a little bit more modern, as well as some changes that are basically meeting gaps in the standard, things that we feel that should be there. So of course we'll talk about the details of those, but as you can imagine, those are the primary characteristics of Java EE7. This is a view of what Java EE7 looks like. So as you can see, there's roughly three groups of changes. One are APIs that have gone through some minor updates. You know, so these are a small number of changes that have happened to these APIs. There's of course the major releases. These are not the point releases, but major changes in the APIs, as well as some new candidate APIs that were added as in JavaEE 7. Before I do that, though, one of my favorite points to make is this little portable extensions box towards, I guess, my right here. So the point of this little box here is to make you realize that this is what we're talking about today, and the changes that I'm talking about today is the tip of the iceberg. So really, the primary goal of JavaEE is to serve as a core development API that people build upon, extend upon. So what does that mean? You know, it means that beyond learning these APIs, you should also be looking to things like Archillion, and perhaps Seam, perhaps Delta Spike, you know, the various JSF component libraries like Prime Faces and the like, and everything else that extend and support build upon all of the respective JavaEE 7 APIs. So let's talk about the primary changes first. The primary changes really are JAX-RS 2.0, EL 3.0, and JMS 2.0. There's minor changes across the board. So as you can see, in the minor changes category, you pretty much have all of the APIs that consist JavaEE. So that's quite a bit of a large number of small changes across the board throughout all of these APIs. And of course, there's new APIs that were introduced, namely the concurrency utilities, batch applications, Java API for JSON, or rather JSON-P as we like to call it, and the Java API for WebSocket. Okay, is there any way of stopping that from happening on the screen? No? All right, that's fine, no problem. So one of the EGs that I was an expert group in the expert group for was JMS2. So I think the changes here are quite important. You know, perhaps I'm a little biased, but I think you'll agree that a majority of JavaEE developers get impacted by the changes in JMS2. So the primary changes in JMS2 really is about modernizing the API. So as you can see, as you can imagine, JMS 1.1 I think is one of the oldest APIs in JavaEE. It hasn't gone through any changes for about 8 years, which is a very large amount of time in an industry such as ours. So one of the primary goals, as I mentioned, for JMS2 is bringing into play, you know, the modern programming practices, like you know, less general purpose and more special purpose APIs, things like dependency injection, things like the builder pattern, things like annotations, and the like. There are a small number of new features. So in the JMS2 expert group, we tried hard to kind of prioritize what these changes are. There are a small number of new changes that did make it in, and those are things like delivery delays, asynchronous sends, delivery count, and MDB alignment. I won't talk a great deal about these things. You know, feel free to check them out by yourself. Delivery delay is basically saying, okay, don't send this message out right now. Send it out after a specific period of time. Asynchronous send is basically to support the folks that need very high performance NIO type environments where you're saying, okay, you know, send this message out asynchronously. Give me an immediate return and then send it as soon as you can. Delivery count is a standardization of something that we've had in JMS for a long time. It's called JMX delivery count. It's basically saying after so many tries of delivering a message fail. This particular property was optional in JMS 1.1. It's now required in JMS 2. MDB alignment is interesting for those of you who do EJB development. In EJB 3.0, and rather in EJB 3.1 as well, there was a few misses as to some standard properties that are very common, like, okay, what destination am I looking, am I getting these messages from, am I listening messages on? What is the connection factory that I want to use, and etc. Those things were not standardized, and hence they were done slightly differently for each vendor. MDB alignment is basically standardizing all of those features. And that's not the end of it. There are, actually this is true generally of all of the APIs that I'll talk to you about. There are a lot of other small fixes and clarifications that have went in. I won't go into the details of that. I think those would interest you only if you were very, very interested in a given API. Okay, so let's talk a little bit about JMS2. So this is how the old JMS API looks like, right? And if you look at it, this code is extremely verbose. But at the end of the day, The part of the functional core, if you will, of this code is really this one line in red called message producer.send. And the rest of it is really boilerplate imperative style code. And the reason for this imperative style code is sort of the mindset that existed in JMS 1.1. Because of the fact that this was a new API, it was hard to kind of overgeneralize. So these are rather make very specific APIs. So these APIs necessarily needed to be somewhat low level and somewhat general, right? And of course, now that we have about 10 years of experience with these APIs, we now know that some of these generic things are not necessary. We can make the API at a little bit more higher level, a little bit more special purpose, and more geared towards what its functional core is. So in an ideal case, this particular bit of code should really boil down to that one line, and that's what we essentially aim to do with JMS 2.0. So what are the boilerplate things here? We all know this, I think. There's a number of intermediate objects that are being created, like a connection, and then a session, and then a message producer, and then an explicit, text message object. And these are all, again, empirical parts of this code to arrive at the functional bits. There's things like explicitly closing every single connection. There's things like having to handle JMS exception, which is a checked exception in JMS 1.1 all over the place. And it just so seems that in majority of cases, you actually don't care, or there's nothing you can do when a JMS exception is actually raised. So it's a bad candidate, again, in hindsight, from JMS 1.1 for checked exceptions. So this is how your new code looks like. Okay, so this is essentially fixing all of those imperative style codes and making a more modern API out of it. So first and foremost, there's a JMS context, and this is a high level, if you will, a special purpose API that kind of models the primary things that you would want to do with the JMS, with JMS as a standard. So it's a high level abstraction over all of those intermediate steps that you created before. So connections and producers and sessions and the like. And of course, we can now use dependency injection to inject this JMS context object. You don't really have to do much of anything else beyond that. All of the rest of it, all the rest of the boilerplate would be taken care of for you. And then of course, the JMS context object itself is broken down into two primary parts. And we struggled hard to see if we can simplify this even more, but it wasn't possible. So what we wound up doing is creating two child objects from JMS context, namely a JMS message producer and a JMS message consumer. But unlike in old APIs, we applied the builder pattern to this. So when you apply the builder pattern, what happens is you can chain method calls. And as opposed to this verbose code where it's not utilizing the builder pattern, you're not having to store the intermediate objects if you don't want to. So you can simply chain the method calls like saying create producer or create consumer, and then simply do the thing that you're interested in doing, the high level thing that you're interested in doing, the functional core, namely sending the JMS message. The other thing you will notice is that instead of creating an intermediate message object, we're directly sending the payload, which happens to be a string out. And this, again, it's a matter of learning, how these APIs are actually used in the real world. In a majority of cases, you don't actually need to use the JMS message object itself, because you don't need to usually set properties, right? So if you don't need to do that, you can simply use this high-level method to say, okay, just directly send out my payload. Or if you really do need to use a JMS message object, you can do so as well. And again, that's made significantly easier through method chaining. Okay, JMS resource definition. This is another thing that was has been a gap. So those of you who are familiar with JavaEE 6, you probably know about the JMS data source definition annotation. So instead of having to define data sources in an application server externally somewhere, you can simply use an annotation or corresponding XML deployment descriptor to define these data sources in a portable fashion right in your application. So as of JMS 2 and JavaEE 7, you can also do the same thing for JMS resources as well. So you can define, as I have in my example, a JMS connection factory and a JMS destination in this way. Okay. those are some of the standard properties that I talked about as well. So destination lookup, connection factory lookup, all of these things were done slightly, destination type, all of these things were done slightly differently prior to EJB 3.2 and JMS 2. Okay. The Java API for WebSocket. I think I won't talk a lot about this because fortunately my well-respected colleague and somebody that I've looked up to for a long time, Jakob Fein, you probably know him better than I do, actually has a talk on the Java API for WebSocket, so I invite you to certainly attend that session. So but generally speaking, let's talk a little bit about the WebSocket API, and I'll leave it to him to go into the details of what this API is. How many people actually have heard of WebSocket? Good, excellent. Okay, all right. So generally, so I won't belabor too much. Sounds like most of you already know what WebSocket is. So WebSocket is basically an effort to overcome a weakness in the HTTP protocol itself. The HTTP protocol is generally stateless, meaning it's a request-response based model. And it's like that for a good reason. The reason being, when you try to scale up a network at a global scale, and you want to have real-time performance of messaging, from one corner of the globe to another, you need a system that is relatively stateless, because stateless systems scale much better than stateful systems. However, there are some cases, and these are legitimate cases, where that falls down. Depending on a stateless protocol, makes things less performant because you really do need a stateful protocol. So those are things like online gaming, stock tickers, where you need rich bidirectional, very native socket-like communication semantics. And this is exactly what WebSocket does. And it does that in a very clever way. Basically what WebSocket does is it treats the HTTP handshake as essentially a handshake. So it uses the HTTP protocol, the request-response paradigm, as a way of establishing a connection between the server and a remote client. And then what it does is, instead of killing the connection right away, it uses the underlying TCP-based connection in a stateful manner. So very much like you would see in native socket-based programming. Of course, in JavaEE and in 2013, we don't want you to be programming sockets. Right? Socket programming is not particularly a fun thing to do. So basically, what the Java API for WebSocket does is it makes developing WebSocket clients and the WebSocket servers as declarative as possible, as productive as possible, and you'll see how in a second when I show you the my code examples. There's two flavors of APIs for Java WebSockets. There's a declarative API that's primarily based on annotations, and there's a programmatic API that looks a lot like Servlet 2.3. So it uses interfaces, and it's a programmatic API. And really, the programmatic API is not geared towards developers that much. It's geared towards people that would build upon WebSockets. These are vendors or some kind of third-party integrators and VARs and the like. So this is really how you create a WebSocket endpoint in Java. It's remarkably simple because you really don't need to know much about WebSockets at all. Okay, so all you'd need to do is, in this case, I have a chat server example. You create a POJO, you annotate it with server endpoint, and you specify, what endpoint URL do you want to talk to. So in this case, we can talk to /chat. And of course, the container does all the heavy lifting for you after that. All you need to do is write this code and deploy it to your server. In this case, I'm maintaining an internal list of sessions, and a WebSocket session essentially represents a connection between the client and the server, persistent connection between the client and the server. There's 3 different callbacks, and these generally correspond to the JavaScript API, corresponding JavaScript API that is there for WebSocket. So these 3 callbacks are onOpen, onClose, and onMessage. Okay, so onOpen, in this case, I'm taking each of my sessions, that newly created session, and I'm adding it to my set of peers. onClose, I'm simply removing that session from my list of peers. And onMessage can be as simple as this. Okay, so you have an onMessage method, and you determine what type of payload you want. So in this case, we've determined that we want a string message, and we've also determined that, okay, I really want to know what client this is coming from, so I'm taking the session as an argument as well. This could be just as simple as just a string message and nothing else. Okay, it just depends on what type of payload you're interested in. So in this case, I'm going through my list of peers and I'm echoing back, the message the string message I received, filtering out the client that this message came from. I don't want to tell you what you told me. I'm telling everybody else what you told me. And that's as simple as get remote, which is a remote representation of your, an object representation of your remote client, and you simply can send out a send object, and all the serialization can be done for you. You don't have to deal with any of those low-level details at all again. Okay, Java API for JSON processing. So again, you can imagine why this API is so important. In this new world of HTML development, whether you're developing HTML5 development or let's call it sort of rich client development, in most cases you won't be using XML. And the reason you won't be using XML is that XML is not a terribly good format for this type of communication. It has several inherent weaknesses that doesn't make it a poor candidate in this realm. So namely, it's very verbose, right? So it takes up a lot of network bandwidth to send back and forth. It's not particularly easy to parse. Parsing it takes a lot of computational effort, and writing XML parsers is not that easy. So JSON really is close to the ideal format in this world. So it's supported by browsers, it's text-based, and it's relatively easy to parse and relatively compact. And a nice side effect is it's not too horrible to read either. Most programmers are able to read JSON and figure out, what is this JSON payload trying to tell me? Whereas XML really is geared more towards non-technical folks, right? So it's very, 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 very declarative as to what the data model is and what each element looks like and the like. What we wanted to do is, instead of having you continue to use very, very proprietary APIs to do this very fundamental thing, namely JSON processing, that's so important in the WebSocket and for example, the REST-based development, we wanted to create a baseline that we can build on. So a standard API for doing JSON processing. So the real thing that you need to understand here, though, is that this is very much like XMLP, right? This is processing, not binding. In reality, how many people use JSON, something like XMLP today? How many of you actually, pull out an XML parser and parse request response, parse your XML body, and use a streaming API to generate XML? How many of you do that? Not very many. Okay. So what are you doing these days? You're doing something the equivalent of, say, JDBC and Hibernate. You're using something like a binding API, like XMLB, for example, or JAX-B, for example. And this is not that API. Okay, so that API is forthcoming and hopefully will be forthcoming very, very soon. And that API will be called JSON-B. Okay, a Java API for JSON binding. And what that will allow you to do is simply take a POJO and annotate it and be able to serialize and deserialize it to probably a JSON stream. But we haven't gotten there yet, right? We're trying to establish the first step, which is let's define the low-level API first. There's two different APIs. There's again two flavors of APIs for this, and again it roughly corresponds to the world of XML processing. One is an object model-based API. It looks very much like DOM, and the other is a streaming API that looks a lot like stacks. And as you can imagine, there is pros and cons of when you would want to use those two particular paradigms, and the pros and cons are very much like they are in the XML world. Okay, a brief example. This is writing JSON using an object model API. As you can see, this is not rocket science. It's pretty simple. It looks very much like DOM. You're creating high-level objects and adding attributes to them, creating arrays, creating objects, adding values as you would need them. Roughly, per line of XML output, or rather JSON output, you'll have one line of Java to do that, which is reasonable. Reasonable, but again, not something you would really want to do. You would really want to use an XML binding API to not even have to write this code. Okay, reading API. This is an example of the streaming API. So again, those of you who are familiar with, for example, stacks, this is very much like that. You're reading a stream, processing each event and saying, okay, what is the event that I'm interested in to get the particular value that you want. So in this case, I'm iterating to this JSON input, pardon me, and getting an event for start object, getting an event for key name, getting an event for the value string, and then finally getting the value itself. Okay. All right, JAX-RS 2. JAX-RS, as you know, is a relatively successful API. Even despite the fact that, I'm sorry, for this particular talk, I don't think I'll be able to take Q&A. If there's time, we'll do it later. Or just get me offline. Let's just talk one-on-one. So as you know, JAX-RS is a relatively successful API. It's a, even despite a lot of competition, it really has become not just a standard, vendor-neutral standard, but also a de facto standard in terms of REST processing. So there actually isn't that much that needs to be done in JAX-RS 2.0. The primary changes that were in JAX-RS 2.0 is really about seeing, what are the incremental things that should be standardized. So there, when they looked at that, when the JAX-RS EG looked at that, what they found was, there's each of the JAX-RS, current JAX-RS implementations like REST-EZ and Jersey and CXF had a number of common things that they did outside the standard. So this is really taking all of those things and bringing them into the standard. So what are those changes? The changes are a client API. So this is where you would want to write a JAX-RS client in Java. The typical use case is probably unit testing, but you could use it if you happen to have a Java client as well. Again, each of these each of the vendors had a slightly different flavor of a client API, and this is a standard API for JAX-RS. There is filters and entity interceptors. So what this is all about is essentially applying aspect-oriented development, if you will, to the world of JAX-RS. So just like you have servlet filters, you now have JAX-RS filters. Just like you have CDI interceptors, you now have JAX-RS interceptors. Okay, and they look very much similar. They look the JAX-RS message filters look very much like servlet filters, and the entity interceptors look very much like CDI interceptors. There's also asynchronous processing, again, for the folks that need that kind of throughput. So it's both on the client and the server side. So you can use asynchronous processing on both on your server side, and if you happen to be developing a client using the JAX-RS client API. There was something added called hypermedia support. How many of you know what hypermedia is? Okay. That's fine. Most of you will probably know more about hypermedia in, say, about a year or so. So let's talk about hypermedia for just a second. So hypermedia, to give you in very layman's terms, is basically applying the concept of hyperlinks to REST-based development. So just like REST is sort of an HTTP representation of how remote remote communication on the web might look like, hypermedia is basically the very same thing. So it's applying the concept of hyperlinks to the concept of REST. So when do these things come in handy? They come in handy in two primary cases. One is where you have a particular resource that you're requesting, and instead of giving you the entire resource, what you can do is give you parts of the resource, and for other parts of the resource, you can simply say, hey, here's a link you can follow to get you that other part of the resource. So one way of thinking of it is it's sort of like lazy loading in ORM and JPA and Hibernate. So you can get parts of the data eagerly and then parts of the data lazily by following links. And also, another use case for this is operations. So you can say that after you've performed this operation, your next operations that are available to you is this. So if you, for example, got a REST resource for an order, that particular as part of that response, you'll not simply get a representation of the order, but you'll also get these interesting little links that tell you, hey, these are the things you can do with this order, like cancel it, update it, and the like. Okay, and those are again expressed by hyperlinks to say, okay, you can follow that hyperlink to do those things. Content negotiation is again another sort of obscure feature, if you will. So what this is, as you know, there is a little bit of capabilities in terms of ad producers and ad consumes annotation in JAX-RS to determine, what type of content are you serving. In addition to that, what was added is something called QS, the QS parameter, to allow you even more fine-grained control over what content you're generating and potentially having a conversation with your client to figure out, okay, what is the right content for both of you, both for input and output. Okay, some brief examples again. This is an example of the client API. So when I show you this, again, this is the client API really could have taken two different flavors. One is a more REST-ish sort of general purpose API, and the other is a much more higher level API that some implementations have, like Jersey has and REST-easy has. And what that is, it looks very much like JAX-WS. It looks like RPC. You literally get a Java proxy to your server-side object that you can now do invocations on. So the direction that they decided to go in the JAX-RS 2AG was to apply the more REST-style low-level API. So it looks very much like you would expect it to look like. You can get a client from a client builder. You can potentially inject this. You specify a target incrementally. You can specify path parameters. You can specify query parameters. You can specify what request MIME types you want, and you can specify finally what a response type you want. You can get a string, you can get a byte, you can get a Java object if you so will. So all of that is supported by the client. A simple example of a filter, and again, this is very much like servlet. The concept of servlet filters applied to JAX-RS resources. You implement the container request filter interface to create a filter, and then you get a callback, and then you can do whatever it is that you want in your callback. In this case, all we're doing is we're logging out the request context. Okay, JPA 2.1 is a point release, but I think there's some interesting features that has gone into JPA 2.1. The first one is schema generation. So schema generation is something that most of you use JPA probably have, are at least familiar with if you're not using. So it's things like, okay, when you tell Hibernate or Toplink, hey, read my warm data and generate my database artifacts for me on the fly. So this is simply a standardization of that particular feature that has pretty much has been there in all of the major JPA vendors. There was finally support for stored procedures, and again, stored procedures are, sort of, the thing that has always been there, and all of the implementations have it, but it is not in the standard. So that was finally added. I personally don't recommend stored procedures. I think it's a little anti-ORM, but if you really need to, you can now use it. The JPA has a standard support for stored procedures. There's something called unsynchronized persistent context that was added. I won't go into the details of what this is, but basically a high-level description of this is, currently in JPA there's two different models. One is a model where the data is flushed with the transaction, and the other is where data is flushed when the component lifecycle ends. So this is sort of unsynchronized persistence context where you can control when data is flushed by controlling when your actual persistence context data is synchronized with the transaction. It comes in handy when you're using things like CDI conversations, for example. Entity converters are a very interesting feature. What entity converters allow you to do is do endpoint conversion with your database format. So for example, in your database, if you have some kind of funky data format that you don't really want to translate into your Java realm, into your Java domain model, you can simply say, okay, when you are coming from the database world to the Java world, automatically do this little bit of translation for me. And similarly, when you're saving out, that particular translation would happen again to kind of convert down to whatever crazy format that you may be using in the database. And again, this is not the end of it. There's a lot of fixes and enhancements. There's a long list of enhancements that you can look at. I'll show you a little bit about the schema generation. So what can be generated? Basically tables, indices, constraints, generators, everything that can can be in the database. When would you want to use this? Certainly for prototyping, and also for database provisioning in the cloud, where you don't necessarily have a lot of access to your database. You can use this schema generation property to generate the schema for you on the fly. And believe it or not, you can also use it in production. So a use case for production might be, where you have these schema generated, and you don't have to generate them into into your database directly, you can choose to just generate the DDL. Okay, so then what you can do is you can go to your DBA and say, hey, this is what my ORM tool is saying my database should look like. Could you use this as a sort of a starting point, to create your database and so on and so forth. So again, and as a result, where you can, the output of your schema generation can go directly to a database. It can go to a DDL, or it can go to both. Where is it read from? It can be read from ORM metadata, or again, what you can do is you can apply a DDL script directly. So instead of the ORM tool generating the DDL scripts for you, you can have the DDL scripts again and sort of developed offline, and you can apply those DDL scripts when the when the persistence context is deployed. So this is again useful for unit testing, useful for development environments and the like. Okay, these are the standard properties. So you have schema generation action, none, create and drop, The default is none. Schema generation target, database scripts, database and scripts. The source where you might be reading your DDL scripts from, the source where you may be dropping the DDL scripts from, and the source where you're using to load perhaps some initial data into your database. There weren't actually that many annotations that needed to be added for this. The primary ones were, I think, index, where you're saying, okay, generate some indexes for me, as well as constraints. Okay, this is how stored procedure support looks like. Again, very similar to how named queries look like. You simply give it your stored procedure a logical name, and then you give it a physical name that corresponds to a stored procedure in your database. And the rest of it, looks very much like pre-existing support for named queries. Okay, JTA 1.2. Again, this was one of those APIs that sort of haven't been updated for a long time, but needed a little bit of an update. The primary two changes that went into JTA 1.2, besides some fixes and enhancements, is a very important capability to be able to use declarative transactions out of EJB. So this actually stands some description. So basically, when we added CDI into the Java E6 programming model, one of the things that has become, I guess, more and more obvious is that instead of having all of these different component models that we have in JavaEE, JSF, Servlet, CDI, EJB, what we can do instead is just standardize the components across CDI and make everything else services. Okay, so this is JTA 1.2 is one of those services. So instead of having transactions tied to the EJB component model, we simply now have an interceptor, a transactional interceptor that you can apply wherever it makes sense, primarily in CDI managements. There was also another important change called transaction scoped. I won't talk in detail about what this is. Basically, if you're familiar with CDI scopes, this is describing a component that lives and dies within the scope of a transaction. Comes in very, very handy if you're actually doing any kind of, if you're developing any kind of custom backend development besides JPA and the like, because under the hood, JPA behavior is very much like transaction scoped. So here's how the transactional annotation looks like. Again, very, very similar to what you've seen in EJB already. There's all of those 3 different transaction types: requires new, mandatory, not supported, etc. And then you can also specify, so by default, just like EJB, what happens is when a runtime exception is thrown, the transaction is automatically rolled back. When an application exception is thrown, namely a checked exception is thrown, you don't get a rollback behavior. And you can basically change this behavior through the rollback on and don't roll back on attributes of the transactional annotation. JSF 2.2, I think is probably, although it's a point release, it's sort of unfair to call it a point release, in my opinion, because there's a very, very large number of things that have went into JSF 2.2. So there is first and foremost HTML5 support. So I'll show you how this actually looks like. So primarily what this means is that you can actually do JSF without having to necessarily use JSF components that may limit your options in using things like Xforms and the like, other HTML HTML5 components in your HTML page. There was something called flow scope that was added. I'll talk a little bit about that as well. View scoped, that was specific in JSF 2.1, was specific to the JSF component model. Again, that made it difficult to use CDI, right? So, because in CDI, this view scope wasn't available, at least in the standard fashion. You could use something like seam faces to get you this capability, but now in JSF 2.0, JSF 2.2 essentially has deprecated all of its own component model-y things, the view scope included, as well as the managed beans themselves. So if you're using JSF managed beans today, you should be aware of the fact that they are going to be essentially deprecated in the future. There's also a file upload component that was added, some view actions, multi-templating, that's again useful in cloud environments, security and the like. This is an example of the HTML pass-through component. So again, if you're using HTML components like color and date, you don't have to wait for JSF to catch up. All you really need to do is you'll be able to use this new JSF scope to kind of bind values just like as you would do in existing JSF components. Similarly, JSF ID and JSF render and the like. This is the flow scope. I won't go through the details of this primarily because I actually am running out of time. So I'll let you take a look at this. Basically what this is saying is it's describing parts of your application. So what happens is you have the conversation scope. And the conversation scope is very, very useful in simplistic cases. But in more complex cases, what you actually want is groups of components that live and die for a particular section of your website. So if you're in the order section, you want a particular group of objects to be alive, okay? And when you move out of the ordering section to say the search section, you want all of those components to automatically be killed, just like we kill objects in Java garbage collection, if you will, and then a new set of objects be created for you. And basically what the flow scoped annotation does is it describes what are the boundaries of these applications. Okay. Batch application support for batch processing was added as of JavaEE as well, or JavaEE 7 as well. So this is called JBatch. This is the primary interfaces for JBatch. It should look familiar to you if you've done any kind of batch processing. This is how an example looks like. So you have jobs, and then you have steps. Steps can be broken down into chunks. Chunks are broken down essentially into reader, processors, and writers. And then you can, batch process these in sets of 10, sets of 20, sets of 50, and the like. There's a whole bunch of other things that were added in the JBatch API. I won't go into the details of that. So things like workflows, things like parallel processing, things like transaction handling, failure handling, and the like. So it's a very, very robust API for doing batch processing in Java now. For those of you who need to do that, as our data keeps growing. Bean validation 1.1 was also added, and the primary thing that was added here was basically again alignment with CDI. So there were some strange things that were missing. For example, the bean validation artifacts were not injectable. You couldn't use the @inject annotation in them. So those CDI element issues were fixed. And the big thing that was changed was the capability of allowing not just validation on bean properties and bean properties, but also bean methods. So now you can validate the input of methods, just like I have here. And this again comes in very, very handy in JAX-RS. And as a matter of fact, JAX-RS supports integration with the bean validation 1.1 API. Concurrency utilities for JavaEE is a little bit of a cryptic topic. So in most cases in JavaEE, we want you to avoid doing these low-level concurrency things, right? The whole point of a programmatic API like JavaEE is so that you don't have to worry about these things. You can simply say @asynchronous EJB, and then all of the asynchronous processing is done for you. However, there are some legitimate cases where you do want to do things like things that look like native thread development, right? So you create a new thread and say run and whatever crazy thing you're doing in there. The problem with doing that in a JavaEE container is that the JavaEE container has its own internal thread pool, number one. And number two, under the hood, JavaEE does a lot for you in terms of context management. Right? There's things like security context, transactional context, JNDI contexts that are all managed very, very carefully in a JavaEE environment. So when you are doing these thready things, if you just create your own native threads, One, you're bypassing the container thread pool altogether, so the container really cannot manage your performance for you at all through its own you're defeating the purpose of having a container thread pool. And you're not being able to use any of the contexts in your native thread, so that you have no idea what security context you're running in because the container doesn't know about your thread. So the JavaEE concurrency utility APIs essentially is an extension of the concurrency APIs that are available in JavaSE, but in a way that one preserves the container integrity by giving you threads from the container thread pool in a controlled fashion, and preserving the container context. So how does this look like? This looks like something like this. So let's suppose you have a runnable task that you want to implement. You'll implement it just like you would in native threads. You'll implement your public void run method. But instead of creating a new thread to do this, what you will do instead is inject the executor service from the container and submit your task to the container's thread pool. Okay, there's other changes as well, like Servlet 3.1, CDI 1.1, EL 3.0, and EJB 3.2. I'll let you just take a few minutes looking at this. I won't go into the details of that because I want to get to talking to you a little bit about the potential changes in JavaEE 8. Okay, so what are the changes that could be included in JavaEE 8? Now, when I tell you this, I need to tell you one thing, okay? This is not Oracle talking, this is me, okay? This is my personal views and my personal opinions of what could be, what could there be in JavaEE 8. And I think this is where you really need to be involved. You need to get involved with me, you need to maybe speak with me, and interact with me, send me emails, or you need to interact with the JCP, or you need to interact with the specification leads. To tell them what your views are, what are the things that should go into the next revision of the specification. So these are some of the things that I think are important, and I think these mostly intersect with what the viewpoints that we have at Oracle anyway. So obviously, first and foremost, JSON-B, right? We want to standardize the binding protocol for JSON. JCache has been there for a long time. It missed the deadline for JavaEE 7 by just a few weeks, so definitely you can expect JCache to be out there probably way ahead of JavaEE 8 and be included in JavaEE 8. And something that's near and dear to my heart really is much more CDI and EJB alignment. So there's a lot of work that I think needs to be done in this space. We really need to get out of the habit of creating custom component models for each of these APIs and standardize on a well-defined, well-understood API and not reinvent the wheel for each specification. There's obviously something that Oracle has been drumming for a little while, and all of the other vendors have been drumming for a little while, like cloud, PaaS, and multi-tenancy. Honestly, I think we really need some input on what this actually means in JavaEE and what is actually useful and needed by developers. I definitely think there can be a next revision of JMS.next. So all of the work that we've done in the JMS API is geared towards message sending. I think there's a lot of work that we need to do in modernizing the message receipt side, maybe even completely superseding the MDB model to create something a lot more modern. JAX-RS.next, there's a lot of things that can go in there as well. Okay, so there's an MVC model that I think is actually quite interesting. So this is where, so JSF has a fundamental problem. So these days, instead of just using JSF, a lot of people are doing very heavy lifting in JavaScript. And the problem with these JavaScript frameworks are they do their work at a very low level. Okay, so they're directly interacting with things like HTTP sessions, cookies, and the like. The JSF component model is diametrically opposed to that. The JSF component model is designed to take away all of that work for you, so you don't have to worry about it. It's a much more higher level API. When you're looking at JSF code, it will look very much like you're developing a client-side application. There is no reference to request, session, all these crazy things, right? Everything is done for you. And that is an impedance mismatch, right? So the way of solving this impedance mismatch is perhaps to introduce another alternative standard web framework that does work at this very low level. And that could very much look like actually JAX-RS, right? And that could operate on on the very low level that most JavaScript programmers are expecting, so the request and all of that stuff, and doing a whole bunch of things manually that JSF does for you automatically. Again, modularity, I think this is an interesting thing that we really need some input on and careful thinking on as to what is it that we actually need, that is needed for majority of Java developers, and how to do it without overcomplicating the platform. There's potentially we could be thinking about standardizing NoSQL, and again, this is an area that I actually will be delivering a talk on this very topic. I think it's later on today. So certainly you can come and listen to my view of what is going on, and what is sort of the current alignment between JavaEE and NoSQL. Sort of as a jump start to thinking about, okay, what is it that needs to be done here, if anything at all. Okay, so well, you're welcome to attend that talk. At least in that case, you will be able to get a bit more detail. Okay, you can download all of this. It's all implemented. It's just almost out the door. You can go download the Glassfish promoted build and start playing around with all these things right away. And I am out of time, and that's perfectly fine. So you can find out more about any of these APIs by going to javaespec.java.net. That's your starting point. It has references to all of the other APIs that are under there. You can of course go to glassfish.org. And you can also I invite you to check out the aquarium. It's at blogs.oracle.com/aquarium. I'm the primary maintainer for the aquarium, and it's basically about news from the JavaEE ecosystem, news from the Glassfish ecosystem that is updated. At least I try to update it daily, not always. For example, when I'm at conferences like this, it's difficult to do that, but I think it's a good resource to follow. Okay, thank you very much. I appreciate your time, and hopefully I will see you for my next session.